Friends, today we discuss class AB push-pull amplifier. The working of the class AB amplifier similar to the class B push-pull amplifier. So here the major advantage of the class AB push-pull amplifier is the crossover distortion is neglected in the class AB push-pull amplifier. So here the crossover distortion is minimized in the class AB push-pull amplifier. So we already discussed what is the crossover distortion means. So here same the working is same as it is to the class B push-pull amplifier. Similarly, the class AB push-pull amplifier have two transistors. So here we can see two transistors Q1 and Q2. So here Q1 is NPN transistor and Q2 is the PNP transistor, can be used in the class AB push-pull amplifier. So here the class AB push-pull amplifier uses suitable biasing networks. So here R2 and R3 is the resistor to use the for the suitable biasing or for the suitable operating point. Similarly, so this transistor, the operating point lies in the cutoff region. So that's why these transistors Q1 and Q2 only amplify the half of the input signal. That means each transistor amplify 50% or above 50% of the input signal or below 100%. Next, the operating angle is 0 to 180 degree. Next, the class AB amplifier amplifies above 50%. I already tell that. Next, same, the crossover distortion is minimized in the class AB amplifier. So here we use two diodes, biasing diodes. You can see here these two biasing diodes. These biasing diodes is uses to minimize the crossover distortion. So we already tell that the crossover distortion means you can see here. So this is the crossover distortion. So this is the output of the class B push-pull amplifier. So this is the output of the class B push-pull amplifier. You can see here. So there is a distortion here. So this distortion occurs so when the input signal below the 0.7 voltage, that means the 0.7 voltage is nothing but the voltage across the base and emitter junction. So below the 0.7 voltage, the transistor is in off condition. So that's why less than the 0.7 voltage, the input portion is eliminated. Less than the 0.7 voltage of the input is eliminated. You can see here. So there is a distortion. So less than 0.7 voltage of the input, the transistor is in off condition, both Q1 and Q2. So that's why, so in the output there is a distortion. So this distortion is called crossover distortion. So this distortion can be minimized using the class AB push-pull amplifier. So in the class AB push-pull amplifier, so we use biasing diodes. These biasing diodes is minimize the crossover distortion. Here diodes also operate at 0.7 voltage. So this 0.7 voltage is equal to the voltage across the base and emitter junction. So both the voltage are similar, so that's why here the crossover distortion is minimized. So next, working of the class AB push pull amplifier. So this class AB push pull amplifier is also provide high power, high efficiency. So we already defined the efficiency. So efficiency means it is the ratio of output power by input power, or output AC power divided by power DC power. Okay. So in the positive off cycle of the input, positive off cycle of the input. So here the Q1 transistor is in on condition and Q2 transistor is in off condition. So that's why the Q1 transistor is conducts, Q2 is off. So that's why it is called push-pull amplifier. The Q1 transistor pushes the input signal and Q2 transistor is pull out the input signal. So that's why it is called class AB push-pull amplifier. So in that positive off cycle, the current is moves like this. See, this is the direction of the current. So in the negative off cycle, so this is positive off cycle and next negative off cycle. So in negative off cycle, Q1 is off and Q2 is on condition. So in this case, Q1 is pull out the input signal and Q2 is pushes the input signal. So in this negative off cycle, Q1 is off condition, Q2 is on condition. So in this case, the current is moves in this direction. So here both the transistor, the output can be taken in the emitter terminal. So this is the working of the class AB push-pull amplifier. So this push-pull amplifier uses only operates in only off cycles, means 50% of the input cycle, because the Q point of these two transistor lies in the cutoff region. So that's why both the transistor only conduct 50% of the input signal and the operating angle is just 0 to 180 degree. Okay, so this amplifier is more efficient than the class A amplifier. So this is the working of the class AB push pull amplifier. So next we discuss another topic. So thank you.